Hello, everybody. Welcome. I see people starting to roll in. Really looking forward to the webinar today. Welcome to the 2024 Hyperspace Challenge webinar series. And today I'm joined by Christine Kretz, founder of Carmen Line Consulting and former VP of Programs and Partnerships at the ISS National Lab. And she's going to act as our moderator today. So welcome. Glad to have you. We're coming live from Q Station. Q Station is in the background there. Really good day here. It's sunny outside in Albuquerque. It's a beautiful day, as always. And as you're listening, I'd love it if you guys would put your questions in the Q&A. That's at the bottom of the screen. There's the option for Q&A as opposed to putting them in the chat. It's easier for us to grab them from the Q&A. So if you would please do that. Also, give us a shout out. Say hello. Tell us where you're from. I'm going to choose one of you guys to shout out on our LinkedIn social media page. So be sure to tell us where you're calling from and your name and your company. We'd love to hear from you. So this is the Hyperspace Challenge webinar series. It is part of an ongoing series hosted by Hyperspace Challenge, as I mentioned, Air Force Research Lab and the U.S. Space Force to strengthen the connective tissue between diverse communities in the space industry. The goal of today's event is to learn about the space test program and also other opportunities for rideshare and funding for those opportunities. And how do we get there? How do we get to space, and how do we test our capabilities and improve our TRL in the process? Thanks again to all of our panelists. I'm going to turn it over to Christine now. She's going to introduce herself, and then our panelists will as well. So glad to have you here, Christine. Take it away.
Thanks, Kelly. Great to be here today, and hello to everybody in New Mexico. I'm Christine Kretz. I'm formerly from the ISS National Lab and currently in my own consulting company. Prior to that, I worked for many, many years at IBM and IBM Research, which is how I met Gary, who's on the panel today. And I'm pleased to introduce the group who's here to talk. Let's start with Veronica. Could you introduce yourself from Space Test Program?
Good morning, everybody. I apologize. I could not get my camera working. The government blocked it and I'm at work. So I work for the Space Test Program, which is a unit that is out at Kirtland Air Force Base, New Mexico. We are part of the United States Space Force, but we are a DoD funded program. And our job is to get experimentation to space that has a military utility. So I've been in Space Test Program for about 8 years. I've been in space about 15, all federal service. I've worked at Space Systems Command my entire career, and I am the Deputy Director for the Space Test Program.
Thanks so much, Veronica. Gary, let's move to you next.
Hey, thank you, Christine. Gary Rodrigue, part of Albright Consulting. And as Christine mentioned, we worked together at IBM Research and then later on at the ISS National Lab. But prior to that, I worked in the IBM commercial side of the business in the semiconductor division. And that'll weave into the talk here because it's highly relevant to some of the work that's being done today. But really appreciate the opportunity, Kelly, and thank you for your efforts to bring this all together.
Thanks, Gary. And last but certainly not least, Peter, can you introduce yourself?
I always love to back cleanup. So yeah, thanks. I'm Peter Wegner. I'm currently a strategic advisor with BlackSky, where I've been for many years since the beginning of that company. Also working on a startup company called BlackVe. And at BlackSky, I was also part of Spaceflight Industries, which at the time was one of the largest launch brokers, commercial launch brokers in the world. We did launches on satellite and rocket systems all over the world. So I've got a lot of experience both on the commercial side, and prior to that, I spent 20 years inside the U.S. government working on satellite programs across AFRL and other parts of the Department of Defense.
Thanks so much, Peter. This is going to be a great conversation, and I will be looking for those questions in the Q&A again. Let's get started with Veronica. The Space Test Program is something that's been a great success. Can you tell us a little bit about how that works and how somebody can participate in the space test?
Okay, so the Space Test Program was stood up in 1967 by the Office of Secretary of Defense, and it was stood up to enable space experimentation in space. Instead of just testing widgets and experimentation on the ground, they wanted a capability so that they can get experimentation up to space and have real world test experience. So what we do is any payload, the key here is you need to be a DoD sponsor, you need to be sponsored by a Department of Defense agency. But if you have some sort of technology that could benefit the warfighter, and what I mean by that is some sort of technology that could help, like boots on the ground, supporting, troops that are out there, we would like to get you up there to get your experimentation done. So how we execute that is those experiments that do have a DoD sponsor, they come to us and we execute what's called the Space Experiments Review Board, and we rack and stack you and we get you launched. You could be number 1, you could be number 79, and we always manage to find a way to get you to space. We do that in a variety of different ways. We can just ride share you on a commercial ride share. Dr. Wegner mentioned he worked at BlackSky, or he's having a startup. Assuming his startup is, like small spacecraft design, we could potentially partner with a commercial company to get your experiment integrated on their spacecraft to fly up there. Additionally, we can procure our own spacecraft and put a bunch of experiments up there to launch and get experiment. We can get we can get rockets out there to get you up there. We can also get you on the International Space Station. STP is the front door for DoD experimentation on the ISS. So currently we have more experimentation on the ISS than even NASA does. And we have a great partnership with NASA. We have a whole group that sits out in Houston with them. We pretty much get supplemented launches from them. So their rockets that NASA already pays for to get, commercial resupply missions. We just kind of use any extra space they have to get our experiments up there. And we can either plop them outside one of the modules on the ISS to operate and get your data down. It can even go inside the ISS and the astronauts can help conduct the experimentation up there and get the data down. So that, in a nutshell, that's what STP does.
That's really awesome work, and there's so many avenues that you offer. It's not just like a one track. So that really makes for lots of opportunities. I appreciate that. And I'll bounce back to you in a minute. But one of the things that you mentioned was outside platforms in the ISS. And I know that, Gary, you have some experience with implementation partners who do those kinds of things and help people prep to be on the International Space Station, including Aegis. Can you tell us a little bit about partners, including Aegis Aerospace?
Yeah, I'd just like to make a comment off of what Veronica said. I think it's really important for this concept of if it works here on the ground, it's going to work in space, and that's not necessarily the case. So what Veronica and her team and what other entities are doing is, hey, put it up in space and let's see how it works, because there are going to be lessons learned. The other thing that I think is really important about this is getting things to space really requires a certain level of expertise. And so as part of the International Space Station National Lab, I have these group of implementation partners that you can partner with, and there'll be a link in the chat that actually refers to that. But I highly encourage, if you haven't or don't have experience or flight heritage, that you really work with a subject matter expert to get your experiments or what your equipment or whatever it is you're sending to space. Now, with regard to the question about the outside of the space station, there are some very unique attributes, and it's really important for people to understand what those attributes are. There was a white paper from Stanford that the first couple of pages talk about those unique attributes like UV, atomic oxygen. And I think it'd be really interesting I put the white paper is going to be in the chat, but it talks about why those attributes are important and how that can affect your work. So with regard to the implementation partners that have equipment outside the station, Aegis is Aegis Aerospace is definitely one. They're probably the easiest and the cheapest way to get to space. Airbus has a platform, NanoRacks has one. So there are a number of implementation partners that can do these experiments externally. And that's important because sometimes the experiments have attributes to them that are not in a very beneficial way for the human habitat. So inside the space station, where you have astronauts, there's a lot of regulations which NASA provides to keep the astronauts safe. So moving your experiments outside the station gives you a wider range of flexibility. Is that?
That's great. Thanks, Gary. And I know that Aegis has, as an example, has 2 planned payloads every year. So that's 2 opportunities to use their MISSI platform. And I think there's at least one person from Aegis who's on the call right now.
Yeah. So jumping in really quick, this is Veronica. He mentioned Aegis. Aegis is actually STP's prime contractor out at Houston that builds the pallets that, kind of dock onto the space station. So those 2 launches you probably mentioned are STP sponsored launches.
Yes, thank you for that.
Let me just interject here, because I would just want to just kind of give people a feel for this. So you could actually fly something on Aegis for from $3,000 to $5,000. It'd be a very small piece that you could put outside the station, but that can give you, and then it goes up from there depending on what you need. But when I say it's relatively easy because of this, every 6 months they're having a flight and the cost, I think that can give you a framework, and then it goes up from there. But it's relatively inexpensive and relatively easy to get those assets to space, depending on which implementation partner you use.
Yes, thanks for that, Gary. We'll talk a little bit more about accessing that too. There's STP and there's also directly to the National Lab. But Peter, let's talk to you for a while. You've worked a long time and with a lot of startups. And I think the big question that people might have is, how do they think about getting to space and kind of what to avoid? What's the best way to go about this as a small business?
Yeah, it's really changed dramatically in the last 20 years, even in the last 3 or 4 years. It's pretty straightforward now to be able to call a launch provider like a Rocket Lab, a SpaceX, one of these companies, and just open a dialogue and say, hey, I'd like to buy a rocket, and how much is it going to cost, and when can I get on, and what's the schedule? It's becoming much more available than it's ever been, and it's going to continue to increase, I think, in that regard. But there's a lot of things that people don't think about. You think about, okay, yeah, I'm going to call and get a contract with some launch vehicle provider and get a launch slot. But do you have a frequency license to even communicate with your satellite when you get on orbit? So have you called the FCC? Have you applied for a license to do that? If you're doing things like remote sensing from space, do you have a license to do that? Have you called NOAA and applied for a remote sensing license? Do you even know how you're going to get your satellite to the launch base? There are DOT transport regulations for hazardous materials and transport. And have you figured out how you're going to do that? If it's a foreign launch provider, what about export? Have you complied with the export laws, with the import laws from that country? You guys have been talking about launches off the ISS. There are human safety requirements to comply with if you're going to go off an ISS launch. All of the US space-based ranges have range safety requirements. So reading through AFSpace 91710, it's available on the internet, gives you a really good initial look at what am I going to have to comply with in terms of ground range safety when I get to the launch range. So there's a lot of things that go into getting a satellite on orbit beyond the point of just building the satellite and getting it ready to fly, that you need to be thinking about really early. And it's happened many times that people launch a satellite into orbit and actually do not have permission to conduct operations, and they're stuck, and they're not allowed by the US government to maybe turn the satellite on or communicate with it until they get all the regulatory framework in place.
You know, Peter, I think that's an excellent point. And I think that's why as you do this, to talk to as many people who have experience is really important. And just as an example of the complexity sometimes, you look at what happened to Varda recently, where they sent a facility up and then they couldn't get it back down because they forgot to close the loop with the FAA. So so the point is, I think you're making a really excellent point there about making sure that you're connecting all the dots and talking to a lot of people who have flight experience.
That's a great point, Gary, and I appreciate it. I was thinking about Varda as well, and I'm glad they finally got approval to bring it back. Otherwise, it'd just still be floating out there. So that's really good news. I am going to ping it back over to Veronica. Luke makes a point that the requirements are harder for the ISS, and it's because of the humans on board, because they kind of come first. But I think Veronica has many more options, but she's not only working with the International Space Station. Veronica, is how do people get in the loop on STP? What's the door to put in a project?
Okay, so the first place I want to send in everybody, I responded in the chat to somebody, but if you would like to get a DoD sponsorship for some sort of experiment or payload that you have, my first recommendation is going to the Space Systems Command front door. It is a whole group of people out at LA Air Force Base, which is the mothership of Space Systems Command. And they are in the process of vetting all of these different vendors and providers that come to the Space Force that have some sort of capability they want to provide. So that's where I would send you first. The other option is to partnership with, like let's say Air Force Research Laboratory or Naval Research Laboratory. Those are our two prime labs that STP gets their experimentation from. I mean, we get them from all over, universities, things like that. So there's also an avenue going to universities. Some of the universities like, let me see, Air Force Space Academy, we launched their payloads. We have launched some payloads on behalf of the University Nanosat program, which is a program based out of AFRL that helps universities launch various nanosat spacecraft, and we help them get access to space by various different ways. So there's a gentleman at AFRL that manages that program. His name is Jesse Olson. He's a good resource to, if you want a partnership with a university to get on orbit.
Thanks for that. I appreciate it. Because I know sometimes the path to getting up is arduous. And so it's good to know that those are options.
Absolutely. And like Peter said, you have to start thinking about these things early. You can build a spacecraft in 18 to 24 months, but it's a years-long process to get frequency requirements, plan your transportation plan, all of those things he mentioned out of, ASPACE 91710, getting range approval. It's a years-long process. So recommend, having somebody that has that expertise so that what's coming ahead and you're not launching a rock on orbit.
No, and there's, the safety concerns. You have to go through NASA safety if you're working with NASA on that. And implementation partners are knowledgeable about how to go through that whole process. We did talk a little bit about, things on the exterior, but also, small sats and CubeSats can be launched. But one of the questions is about disposal of those. And Peter, I wondered if you had any thoughts about, you can get it up there, but what are the requirements for disposal?
Yeah, it's a great point. The United States is a signatory to the Outer Space Treaties, and those come with some, I wouldn't necessarily call them requirements, but they are accepted norms of behavior that say, I think the requirement currently is that you have to deorbit within 25 years of launch. There is some discussion about shortening that to within 5 years. And in the United States, the regulatory body that's responsible for ensuring that you do that is the FCC. So when you go to get a frequency license for your satellite, one of the things they will ask you for is a disposal plan. And part of that disposal plan is also an analysis of your satellite re-entering and burning up in the atmosphere and ensuring that it's not going to impact somebody on the ground when it does so. So there's a whole process that you have to go through when you apply for the frequency license to also ensure you're complying with the mitigation and disposal plans.
No, I'm actually glad to hear that, because when I was working at the National Lab, I only knew about the parts where they went up. So the disposal is news to me. So it's good to know that they have that plan. I am going to ask a question from Ryan here. He's asked about software. So Veronica, do you have any software missions specifically instead of just hardware that you work on?
So we do. The software piece really comes into place when we do ground system development. So you send something up there, that's great, but how are you going to communicate with that thing that's up there? And what you need is you need some sort of ground system. You need some sort of software on the ground that is going to take your command and telemetry data and process it. Can get a little complicated if you have classified requirements, but basically we focus on heavy software requirements for our ground system development. There's a bunch of different ways the Space Force and commercial companies use that. There's commercial augmentation systems available. There's also certified DoD systems available, and we're working on currently Space Systems Command here at Kirtland is working on a cloud-based system. So yeah, software is heavy for the ground development side of operating your satellite while it's on orbit.
That's very helpful. I also am aware that HP has a supercomputer on the International Space Station that is accessible. If you wanted to get in touch with them, you can probably do that through the National Lab. And I think Gary's listed some or has some links in context for that. And you can upload the software through them, and then they'll send you the data back. So that's another opportunity if you're trying to test software in space. And I've had some customers who've done that. Let's see. The other question about things is funding. So I was going to change this over just a tiny bit to the funding side. And Gary, why don't you talk a little bit about how the National Lab does funding, and then we'll go to everybody about different funding methods that they're used to. But Gary, tell us a little bit about those NLRAs and NASA's NRAs.
Yeah. So one thing that I want to stress before or just a recommendation that I have started to see a lot more focus on is this whole business model. So I think it's my counsel to you is if you're going to apply for funding via an NRLA or an SBR, that you put as much work in your business case as you do in your technical case, because there's this whole drive right now to figure out commercialization of LEO. And because there are such limited assets, people are really focused on, or people are starting to focus on, how does this tie to an application, a marketplace? So I would encourage you to look at and spend a lot of time thinking about your business case. In one of the links, there's a white paper that was done on biomanufacturing in space. And in there's a really good business case analysis. And you could use that kind of as a basis, and then maybe reach out to subject matter experts in the business community. But specifically to Christine's question, CASIS, which is also referred to as the International Space Station National Lab, has these NRLAs. Now, the thing about, and they come out relatively frequently on a quarterly basis, maybe even a little bit more, just depending. But they usually have an applications focus. But the thing about that NRLA from the CASIS is that it is you have to be ready to go, and you have to have you have to have done your ground experiments. Now, the difference is with NASA, they have a NRLA that they announce, and that comes out depending on the application once or twice a year. And that allows you, the first phase of that allows you for ground experimentation. So it depends on where you are in your process. But so maybe there's an opportunity to work with CASIS and then move to the and do some work, or start with the International Space Station national lab and then moved to other funding mechanisms. I also want to mention that the NSF has a space directorate, and they have seed funding programs that go for about between 200 and 300,000. That's a relatively easy process to apply for. I know they're actively funding that. And so that is another option for you. So there are a plethora of funding mechanisms that it just depends on where you are in your process and what your goals are.
Thanks for that, Gary. Peter, you may have had different angle and approach to funding than going through the National Lab or NASA. Can you talk a little bit about things that you think are options and how people should best prepare for that?
Yeah, I've spent a lot of my time the last 8 years on the fundraising side, having started BlackSky, and we raised over the course of building that company and taking it public 2 years ago, more than $500 million in private capital. So one option is certainly to work through the venture investment community, and starting with very early angel investors to get a startup company off the ground. There are a number of angel investors, even some here in New Mexico, who are very interested in investing in startup companies. Once you graduate from the angel investor class of company, there are just a large number of venture capital investors who now are very interested in space. Again, going back 10 years ago when we started BlackSky, it was very new. There were not many venture capital investors who thought that there was a viable business to be had in space. But thankfully, that's really changed, and there's a really robust interest in venture investment now. So getting involved in the venture community, Hyperspace challenge are great opportunities to get engaged in those kind of communities and investors. But there are a number of other sort of incubators around the country where you can enroll and learn how to build a pitch deck, how to build a business plan, what does it look like, and then ultimately, if you're successful and really lucky, you can take that company and roll it into the public market, where you can raise money as a public company in the stock market. And it's really, I think, an amazing capability or an amazing system we have in the United States that really feeds this innovation engine with that kind of private equity investment and venture investment. It really is a dramatic, game-changing innovation engine that we have in the nation that it really does not exist anywhere else in the world. So I would urge everybody, jump in. It's an exciting ride. It's not easy, but it's fun.
Well, and it is exciting. I mean, when dating myself as to the original space race that I grew up with, and then the shuttle program, a lot of that was, the government funding and things. And now there's, I think, much more opportunity. I'm based here in Florida, and just watching Blue Origin grow and small other, startups over here on the Space Coast. It's really quite a commercial entity and lots of opportunity. So that's exciting. Veronica, do you have funding mechanisms as part of STP, or do people come to you with a DoD already funded project?
So either or. Primarily, the vast majority of our experiments do not come with their own funding. The key thing for us, though, is STP per our charter. We cannot pay for the experimentation development. So you have to come with some sort of widget or experimentation or payload that's already built and developed or on the way to be built and developed. What we pay for is getting you to space. So that's any integration costs getting you on to a spacecraft, a rocket, the ISS, whatever that may be. We can pay for your ground system development to develop your ground system to get your data down. We can pay for your operations costs, because once you're up there to get to operate it, there's a cost there too. We can pay for that. But that's kind of what we're limited to paying for. But those are actually some really big costs, because some people coming, with a 12U CubeSat they're not going to be able to afford to get their own rocket. Rockets are hundreds of millions of dollars. So we provide you that access, and we pay for how to get you there. That's the value that STP brings to the table.
And that's a lot of value. So there is a question about whether you have a list of upcoming launches for STP. Is that something that you make available?
So we don't necessarily have our own list that we publish just for STP externally. Obviously, we have something internal, but all of the upcoming launches are publicly available. They're usually listed. You can go to Space Launch Now, spaceflight.com has one. They're all available coming up. But any of those, what is available to the community, though, any kind of commercial transporter launch, we have access to get you on there. So we have a payload coming up on Transporter 10. That launch just slipped from March 1st to March 4th. We have some payloads on there. So any kind of commercial launch that's out there that's already on the manifest, STP has a way to work with whatever company is launching that rocket to get on there. Peter mentioned Spaceflight Services. We've worked with them over the years to help get the DoD experimentation access to space as well. So there's lots of commercial opportunities available.
Thanks. And I don't know if Kelly can find one of those links. I use one of those here to make sure I don't miss because I can see them from outside. So anything that launches out of Canaveral, I like to keep up with. So to the person who asked that question, I think we can, you can find one that gives general, if not specific to Veronica's flights on STP. I think there's another question about whether foreign entities can be sponsored for DoD. So I'm going to let Veronica answer that for STP, and then Gary, can you answer that for the National Lab?
So from an STP perspective, yes. I mean, pretty much anything is possible. Right now, we are standing up what we call the ISARB. It's the International Space Access Review Board, and it's similar to the process I mentioned earlier, but it's for international payloads. And we're working with the Pentagon and the IA shop out there, the International Affairs shop, on working on getting agreements so that we can launch, Five Eyes payloads and our allied partners projects. If you are an allied partner company, potentially, you would have to go through the whole front door process to get vetted to see if we can work with you. Another avenue for you, if you are a Five Eyed partner, is go directly to your Department of I don't know, your equivalent of Department of State. I'm not sure what it's called, and see what kind of payloads your country, your military is launching, and work with it through that avenue as well. That's another option.
And then Gary, there's a ruling on using though it's an international space station, the ISS National Lab is US based. How do they manage that?
Well, yeah, I think it's very interesting, and it's a little bit complex. Obviously, if you're in the EU or Japan, partners on the International Space Station, it's a little bit easier to collaborate. But to be clear, the mission of the ISSNL is really US centric and for benefit for the US government, because the US taxpayers are paying for that. So while it adds a level of complexity, I will say if you're from other countries like China or the list, then that's going to be very, very challenging and problematical.
Let's switch this over and talk a little bit about timelines. Peter, you talked about it's going to be a marathon, not a sprint. Takes a long time to do these things. Can you talk a little bit about that timeline? What is going on? How long does it take? And then maybe Veronica will go from there and talk about once you are this far, how long does it take to actually get up into space? Because it's a whole thing.
Yeah. It's hard to nail down, in my opinion, a specific timeline because it always depends. It depends on a lot of factors. I've seen it go very, very fast. When I was at spaceflight, we showed on a number of occasions that we could swap CubeSats in and out of a launch very, very quickly before the launch itself. I don't know if I can quote off the top of my head specific number of days, but it was certainly measured in a matter of months that we are able to take one CubeSat off and put another one on in the same deployer. And you know, that's possible if you have all the paperwork set up, you have all the range safety done, you have all of your frequency licenses and all that done. It's possible to get on a launch very quickly. But I would say starting from scratch, you know, clean sheet of paper, satellite design, build, starting the licensing process, you should certainly be working that about 36 months before launch. That's a pretty comfortable timeline, in my opinion. If you push it to 24 months, that's starting to get pretty tight. And if you're inside of 12 months, it's probably not going to happen.
Yeah, it is a lengthy time, and there's also, I'm aware, you know, NASA in their launches and SpaceX, they've got a list of payloads that they've got racked and stacked. So I think Veronica maybe has the best in with any of them as a partner on STP. Any other thoughts, Veronica, on the timeline and what it takes?
Yeah, so I agree with Peter. If you're starting from scratch, it's going to take 36 months, maybe a little longer, just depending on a lot of different things. But if a payload comes to STP and it's already ready, we can get you launched in 3 to 6 months by, you know, like on a transporter mission. If you come and you still have a lot of design work to do, which happens, we're still looking probably at a 24-month timeline. We will help you with your frequency license too, but you're not going to get a frequency license in 3 to 6 months. As he said, it's going to take a couple of years to get that. We do have avenues to help you get that though as well. But it really just depends on where the actual experiment is in its, you know, design life. If it's pretty ready, we can get you launched pretty quick. If it's not, it's going to take a couple of years.
Yeah, and I think that's, you know, when we look at just a couple of things here, I'd like to add. When we look at the going to CASIS or the International Space Station National Lab, they have about a 24-month line or queue, if you will. But there are other options that are available. For instance, I'll talk about Aegis for a second, but then move to some other options. Aegis really requires the flight articles about 5 months before. So if you're ready and you have your concept, they're an option. The other piece of this that's really interesting is Aegis can handle any samples from an inch square all the way up to 24U. And so that's an option. The other piece of this that I think is really fascinating is that there are other vehicles that are coming online. And that's going to open the aperture in a very big way. For instance, Above Space has a flight that's going to be happening, I believe, towards the end of the year, and then another one in 2025. So those would be unmanned facilities, but that's there's an opportunity there to get to space quicker. In addition to that, you have the Varda platform that's coming online and a number of others. So what I'm particularly excited about is this additional capability is going to just help us get more data, more information, more experiments. And that's going to just act as a catalyst to driving us forward, because the learnings that are going to come from this, whether it's in advanced materials or biologics or whatever, is going to be just incredible, because we're going to be able to get things up there and get the experiments done, get the data, and then make more informed decisions. So I'm particularly excited about where we are right now. I think we're just on the infancy of something very, very big.
I think that speaks to Peter's point about the many opportunities. And I know, for example, Above Space, they're unmanned, so they don't have some of the restrictions that like the International Space Station does. And they take payloads, to my understanding, as big as 75U. So they can take a pretty large size payload, exterior payloads and interior, which is certainly interesting. And that's just one. You mentioned Varda as well. I think VAST is doing some things. So the private sector is really wading into this. And I'm sure that Veronica works with, you know, all of those different opportunities to get her payloads up. but certainly is an exciting time to be in in aerospace. And I'm sure everybody who's here on the call as attendees are all nodding their head in agreement. So there's that. I'm going to put out an open question that I haven't answered from the Q&A, and I don't know if anybody has the answer to. How do you move your SBIR 1, 2? How do you get to a 3? Like what is the advice that anyone who knows how to get from SBIR 1 and 2, how do you get to that SBIR 3?
Well, let me take that, and I'm sure other people have thoughts on it. I think the net of it is it takes a real team, and it takes a building an ecosystem. And one of the things that I've seen is from best practices from some startups is they have a board of advisors and that sit on this, and this board of advisors they're subject matter experts in everything from, depending on, in this particular case, it's a bio application. So they have subject matter experts from industry, they have subject matter experts from the FDA, everything that is required to get to that end stage. So building up that is, I think, important. Then I think Peter mentioned it. There are these accelerators, like for instance, Mass Challenge and other ones we're talking about exactly Hyperspace, but that is really important to get with these accelerators because they can provide insights that are very important. And when we look at the funding of these SBIRs and moving to phase 3, looking at that total package, looking at, not only, as I said earlier, not only the technical components, but who's your team? Who's your business development team? Who are the people on your advisory board that can open some doors for you? And then obviously, and I think this is really important, is connecting and establishing relationships with the VC community very early on, because they can provide a lot of insights and address a lot of pitfalls that might happen.
Thanks for that. Peter, any thoughts on, you've been, in this industry for longer than I certainly have. So I'm used to working with people who are in their phase 1 and 2 SBIR, and I really haven't coached too many in phase 3.
Yeah, I've had experience with this both on the government side in my time as a federal civilian, and also experience on the commercial side. To me, it's a really kind of simple answer, and that is, to get to phase 3, you have to have a commercial product, and you have to have something that somebody wants to buy on a commercial basis. Phase 3 is not about more research. It's not about more R&D. It's a commercialization contract, and it's supposed to be the graduation of your phase 1 and 2 research into a commercial product. And there are a lot of examples of this that I was involved in my career. The development of the Esper ring was done on an SBIR and transitioned into a phase 3 SBIR. And there were there still are today, many Esper rings being built and flown. A lot of early vibration isolation systems, low shock separation systems, we developed on SBIRs and converted those into SBIR phase 3s so that the government could buy that as a commercial product. But that's really what it comes down to, is do you have a system that the US government wants to buy as a commercial product? And can you produce it at scale? Can you really operationalize it? And if you can check all those boxes, then you have a chance at least to go present a case to convert that into a phase 3. The other thing I would say is that it's much better if there is customer pull than if it's a company push. If you're trying to push it on the customer, you may not have a good product market fit. Your product may not meet the customer demand. So if you can get to a point where you've got really good product market fit and there's just insatiable demand for your product, the phase 3 is going to happen naturally.
Peter, I couldn't agree with you more. I just, to give you an example, I want to give a concrete example. For instance, the NASA INSPIRE awards, when you move to well, you start with phase 1, that's 100% funding from NASA. You move to phase 2, it's 20% from an outside entity,
Yeah.
and 80% from NASA. Then when you move to phase 3, it's to your point, it's 80% outside funding and 20% from NASA. So this whole linking to the marketplace and making sure you have a product. When you're in phase 3, you're not doing research and development. So
Yeah, that's right.
Well, and that's an interesting topic, and I'm going to ask all of you for your input on this. To have a product that is marketable, there has to be that draw, there has to be a need. So what do you see is a white space? What is missing that somebody could be developing, but you're not seeing it in there's a lot of CubeSats, there's a lot of satellites, there's a lot of stuff. What aren't you seeing that you think there's opportunity?
well, I can start, okay, but I really believe you. And my background, I've been working with CASIS and in NASA INSPA, but I think we're on the tipping point of something very huge in LEO for terrestrial benefit. And so when we break it out into 2 categories, I think it's advanced materials and then it's biologics. And I think that because of the unique environments and attributes of the LEO environment, we're going to have breakthroughs, technological breakthroughs in those 2 pillars that are going to be totally transformative. If we think in the biologic space, the millions and millions of dollars, just one category, osteoarthritis, right? Today, there's been research done, billions of dollars spent, and patients are still told to go home and take 2 aspirin and rest. That is not acceptable. We need to, the thought is there are areas in each of those technology pillars where we're hitting the wall. And I personally believe that in the advanced materials space / semiconductors, there's a huge opportunity for us to drive innovation, US leadership, and address national security concerns. On the biologic space, when we look at everything from cancer to glioblastoma, there is an incredible opportunity for us to innovate using this new technology platform called LEO, manufacturing in the LEO environment. I think is going to be absolutely transformative and is going to have huge societal benefits. And so I am just particularly bullish. I think we're on the cusp of something really, really major that's going to propel us for the next 20, 30 years in innovation.
And then Veronica, from your standpoint, you're coming at it from test programs. Is there anything that you're looking for that you haven't seen develop that you'd like to see?
Yeah, so I think one of the things that we've talked about over decades, and Peter can probably agree with this, and we've made vast strides, but we still have a gap in, I guess it's modularity and in our interfaces. So when we get, experiments in and we have to integrate them onto this thing, we have made, vast improvements in, standardizing interfaces, but there's still a gap there. We still struggle with, because to design mission unique hardware, that would be an STP bill that can get really expensive. So for example, if we get like a bigger spacecraft and we're putting on a big, what we call a national security space launch, mission unique integration for one of those big launch vehicles can cost $16 million. And STP has an annual budget of $25 to $30 million. That's half of our budget for one launch, potentially for one spacecraft. So I think there's still a gap in standard interfaces. And how can we, I don't know if there's some sort of like modular interface that can be designed, but that's where I see like those real smart people out there that are trying to come up with new innovative, ways to help space. That's one big thing I could see is to continue to figure out how we standardize those interfaces. We do have standards, but there's still a gap where they just don't fit. It's kind of like putting a block in a round hole, and then we have to design this interface to attach the block in a round hole. And if we could figure out a way to make that more affordable, and I always think of like some sort of like modular adjustable interface on a spacecraft or on a launch vehicle, I think we could save the government and therefore the commercial sector a lot of money, and they can pump their money into actually designing new and good products as opposed to having to pay to, make things fit. So that's the biggest gap I see from a government perspective.
So Veronica, thank you for that perspective. I had not even thought of that. And I think that's really, really important. Because one of the things that, when I talk to researchers and we talk about is not sending one experiment up and bringing it back down, but how do you send one experiment up and iterate it 50, 100 times and get that data? Because that's where the learning is going to be. And to your point here, what you just made, I think is totally fascinating. It's something that we, as a community, I think we need to really come together and think about deeply, because at the end of the day, it's going to be about getting data to make more informed decisions.
Peter, anything to add to that? I know you're nodding, so it looks like you're in agreement. And I didn't know if you had something else that you thought was missing that people could go after.
Well, I think Veronica's point about modularity is an interesting one, because I think we're still in a bit hamstrung by our legacy space kind of mindset. And in the legacy mindset, the satellite was the product. And so all of us aerospace engineers got together and we, really geeked out on building our satellite and how great it was. And every single one was kind of Swiss watch built. But you really have to make this mindset shift that the satellite is not the product. The product is the thing that you do with it and the customer that you're supporting. And we're starting to see this, this space ecosystem and economy really accelerate. I spent the last 10 years in remote sensing and doing commercial remote sensing, and there's still a lot of gaps there. I think in the future, I envision that we'll have literally thousands of satellites in orbit monitoring the entire electromagnetic spectrum emission off the face of the Earth, feeding that into big data machines and analytics, AI systems that pull out the critical information, whether it's climate change or national security issues or border security issues. And so there's a lot of work just to be done on the commercial remote sensing front. I think we're on the very tip of connecting space to our mobile devices. We're going to see in the next couple of years a lot of companies emerging that are connecting satellite backbones into your handset directly or through other links. And that's going to open up a whole new realm of data transmission, data storage, onboard, on-orbit processing for high-performance data systems. But you gotta, and when that happens, the focus on the satellite itself, the satellite is going to become the commodity, and commodities move into standardized interfaces, standardized products. And I think we're going to see that evolve as the economy in space grows and really puts the, pressure on engineers like us to design things faster, get them up there faster and cheaper. And I think that modularity is going to be a key component of enabling that.
Thanks for that, Peter. I think there's a question about data and the kind of data that you can get back from what goes up, what can you get back? And I know, Peter, you were talking about radio and all that stuff. Can you take a dip at what can you get back when it's up there?
Yeah, maybe the question is getting at, are there limitations to what you can do? The easiest answer, I guess, is you can get as much data as the sensor that you put up there. So if it's a RF sensor, you can get that data back. But if the question is, are there limitations on what you're allowed to do and what data you're allowed to collect? I don't know that there's a limit. I can't think of one. I mean, certainly there are limits to how close you can get to another company or another country's satellite. And those are, determined to be sovereign assets, if you will. So It would certainly be against the outer space treaties to go and drill a core sample out of somebody else's satellite and get that data. But aside from that, I think, yeah, it's a wide open domain. If you can build a sensor, get it on space, get it on orbit, and collect the data, you can get it down.
So one of the limitations I can kind of think of, jumping off of that, is from your ground system perspective, we are moving towards more commercial ground system solutions. And as more companies stand those up and more companies start using them, you could run into limitations on how many, times you can contact your satellite. If you have an experiment that you actually need to command and control it and move it around up there, you could have some limitations, using a commercial ground solution on how often you can do that. From an STP perspective, we tend to, if I'm going to go out and buy a spacecraft, I'm going to put as many experiments on that thing as possible. And, you could have a limitation with another experiment that's on that spacecraft because they might want to use it during that time. So it's just an organizing thing. So those are some limitations that I can see, if that helps answer that question.
That's a good point, Veronica, and I'm aware of that kind of, sharing of the payload with the different requirements that each payload has. It's kind of like playing, Tetris while you're putting that stuff together. Hey, we're about in an end, and I just wanted to thank everybody for doing the call today. I know there's a few more questions, and I'm guessing that if you direct those to Kelly, she can make sure that they get to the speakers, and I'm pretty sure that everybody who's on this call will be happy to answer those questions even offline. With that, Kelly, thank you for having us today. I'm going to turn it back over to you.
Oh my goodness, that was so awesome. Thank you, Christine. You did a great job. You're an expert at moderating. Really appreciate you taking over that. And you guys, the panelists, you guys are awesome. I appreciate you, and thanks for being here. To our audience, our next event will be Navigating Space Symposium, the strategies and insights for startup success at the industry's most recognizable annual gathering. So you guys won't want to miss that one. We'll have Kelly Kiedis Osborne, who is the Vice President of Space Commerce and Entrepreneurships at Space Foundation. We'll have Michelle Fleming as well, who's the Director of Strategy and Innovation at SpaceForge. And we're hoping to get one other guest, but you're just going to have to stay tuned to find out who that is because it's not confirmed yet. But that'll be March 14th. So go and sign up for that. I think Demetria is probably putting the link to that in the chat. And then also, guys, this conversation didn't tell you, I think this is a perfect segue for the ACSP. It's called the Association of Commercial Space Professionals, nonprofit here that is hosting the 3rd Space Regulatory Boot Camp on March 4th through 7th. So learn what you need to know about policy and regulation. And it's for compliance, business development, or legal professionals in the space, aerospace, or tech sector. So you guys are the audience. You should go sign up for that. You should use the code ACSP15 to receive 15% off. So go do that soon. You can sign up right up to the day of the start. So we have the website hopefully in the chat as well. Last thing I'm going to tell you guys about is the Space Fiesta here in Albuquerque. We are hosting a space event that you all need to come to. We're going to have universities from across the United States there. We are going to have New Mexico space industry. We want space industry from everywhere. So please sign up on the interest form if you're interested. That'll be June 6th here in Albuquerque. And we're really excited about it. I think it's going to be a fantastic event. We want everybody in the space industry to join. So please do that. This will be recorded. We're going to have it on our YouTube channel. So go there and sign up, subscribe, and please like,
and share,
and subscribe. We've got 36. Come on, guys, we can do this. Let's get more. It's going to be good. So And also sign up for our mailing list so you can be, up to date on what we're doing. We're always thinking of new things. We're trying to get involved, building this community. And I think, webinars like this are just the tip of the iceberg of what we're trying to do. So, yeah, so great to have you all, and please enjoy your day. And yeah, reach out if you have any questions. And thanks again to all the panel. You guys are amazing.
Thank you, Kelly. This has just been
Thank you,
fun.
guys.
So really appreciate you pulling it together.
Yeah, sure. All right. Have a great day.
Thank
Bye-bye.
you.
Bye.